Strong acids and strong bases have large, well, the strong acid has a large Ka value. It ionizes completely. So whatever the concentration of the strong acid was, is what we consider to be the concentration of the hydronium ion. Okay, caveat, you might have something that can give up more than one hydrogen, but that's rare. Like the only one that we ever talk about is sulfuric acid. We'll get to it later. Therefore, the pH with this, our normal situation applies, and in place of this hydronium ion concentration, we can just put in the concentration of the strong acid. For the strong base, we're going to, if we want to calculate the pH, the easy thing to do is to calculate the concentration of the OH, and again, with a strong base, typically we just have one hydroxide come out of a strong base. There are more exceptions for this than there were for the acids. You might have twice as many, and therefore you'd have to say something about this being twice as big. But we can calculate the pOH from that concentration, and then we can take the pOH and go to pH using the formula. We have our little rectangle where we can move from one corner to any other corner. So what shall we do now? Let's do one. And just because, we'll go ahead and we'll do one that's a little entertaining. We'll take calcium hydroxide. It is a strong base. It's when it's in a solution, it's called Kalkwasser in German. You can think of that as being sort of like the word for chalk, all right? And lime water is what it commonly is called if you were going to go try to buy some. It's a saturated solution of calcium hydroxide. Saturated, that means you can't put any more in it. It won't dissolve. It gets used if you have an aquarium, if you're trying to change the pH, and the critters in there like having calcium because they're making their little bones and their little structures out of it. They want to know what's the pH if the concentration is this. Okay. My concentration then is going to be 0.0225 molar. That's my concentration. I don't know why I put that in brackets, but that's all right. I'm thinking about it. That's my concentration. All right. What happens if I dissolve it in water? It's going to fall apart, and I'm not even going to put the water in here. I'm just going to go ahead and say it can fall apart into calcium ions, and it would form 2 hydroxide ions. So if I want to deal with the concentration of OH minus, it's a strong base, one-way trip, it's all going to fall apart. This was 0.0225 molar. It should be twice that for the OH. So this is going to be twice the concentration of the calcium hydroxide. Therefore, it's going to be double this. And I know that that means it's going to be 0.0450 molar, because that's double. If I know the concentration of OH, I can figure out the pOH minus the log of the OH minus. So minus the log of 0.0450. Your calculator will spit out a 1.35. The pH is 14 minus the pOH. So 14.00 minus the 1.35. Wow, 12.65. Yes, that's a very basic solution.